There has been a significant increase in the lifespan of the general population over the last 100 years due to an increase in the availability of medicine, clean water, and overall expansion of health practices. The life expectancy has risen from 50 years for those who were born in the 1900s to 81 years in developed countries today. Millions of baby boomers in the United States are coming of retirement age, and it is projected that in the next 20 years, the population of individuals 75 years old and over will increase by 15% compared to other previous decades. According to the CDC, one of the major problems that the elderly face is not illnesses, but actually falls. They report that 1 of 3 adults over the age of 65 have significant falls. However, only half these individuals talk to their healthcare providers about them. For the elderly population, falls are the leading cause of both fatal and non-fatal injuries. Fractures of the hip, spine, forearm, upper arm, wrist are among the most common injuries sustained during falls, many of which leave the patient unable to move and oftentimes unconscious. Additionally, falls that do not leave the patient injured still affect the mentality and confidence of the elderly. After a non-injury fall, the patients tend to limit their physical activities for fear of falling. Our device fills this gap in the medical market by automatically alerting family and medical services of a fall when the patient cannot notify anyone themselves. This device has the potential not only to save lives, but to give the patients more confidence for physical activities. By providing an email alert to family or friends with the GPS coordinates and analysis of the fall and heart rate, we are providing a service not only to the elderly, but also to caretakers and other loved ones. Our wearable fall detector and monitoring device can be used to constantly monitor the user's heart rate, GPS location, and position or speed for falls. A heart rate sensor, a GPS module, and a 3D accelerometer will be used to evaluate each measurement respectively. The system uses a National Instruments MyRio device for all data acquisition, including GPS coordinates, heart rate, and accelerometer data. In fact, the 3-axis accelerometer that we use to measure sudden changes in a patient's position and speed is built into the MyRio device. The data is then read, analyzed, and displayed through LabVIEW and its simple user interface. The heart rate sensor needs to be secured around a patient's finger in order to provide accurate readings. The GPS module is used to monitor the location of the patient and will be pulled up on Google Maps. The current prototype is not really a wearable device. However, final production design would include all sensors in a small package that can be worn on the wrist or waist of an individual.
So when we first start the device, the system prompts the user for their personal information in order to initiate the device. And then the patient goes on to turn the device on in order to actually begin calibrating the accelerometer data in order to determine whether or not a fall has occurred. The backbone of our program is really analyzing the accelerometer data, and we do so in 2 ways: the time domain and the frequency domain. And we do this in order to make sure that we do catch any and all falls, but do not miss any falls. So we go through a lot of different validation steps in order to see whether or not thresholds have been exceeded to determine whether or not a fall has occurred. If a fall has occurred, we then prompt the user to ask whether or not they would like to send an alert to a third party, perhaps a family member, or to 911. And we have an email detection, email processing and sending program over here, which can send the email out to alert other authorities. Beyond that, if the user would like to call for help, even in the case when they have not fallen, they can call for help on demand. Aside from the fall detection, we also do some GPS location acquisition because we thought it was important to know where the patient is, especially in the case that they have fallen. And so this actually uses the GPS sensor based off of the MyRio device. In general, we are interfacing between the MyRio system and the MyComputer system, and so the main program does run off of the computer, and we are using global variables to exchange the raw data collected from the MyRio in order to process it using this main VI that we have developed.
The program is now running. Since it's the first time that the user is using the device, it asks the user for the personal information. The user inputs personal information such as first name, age, and an emergency email. Usually, if this user has used the device in the past, it will not prompt this information as it will already find the file name. Now the user can turn on the device and put on the heart rate monitor. The heart rate monitor takes a few seconds to calibrate, and after calibration we can check to see if a fall has been detected. Since this is not currently a wearable device, the user will simply hold it, but in the future the user will wear it. A fall has now been detected. It asks the user if they want to send an alert. The user can press yes, or it will simply time out. Now we can go to the email and we can see that a fall has been detected and the fall is rated strong, and it has an urgent Max needs help title.
This past semester was challenging, but we are really proud of being able to create a device that integrates various sensors into a single unified design with an intuitive user interface. Our design effectively helps to predict falls, and who knows, we might one day choose to develop the product into a more compact, wearable device that can help seniors live more enjoyable, stress-free lives. We are also proud of our resilience and ability to step away from our Arduino model to the MyRio device at the last minute. It is road bumps like these that are not uncommon in the real world, and we are proud that we handled the situation in a way that would allow us to deliver a working device given the time frame. This was a fun assignment to work on, and we are thankful to have had the opportunity to have a taste of engineering in the world outside of academia.